Okay, it's Mr. Benson here with a short video on finding the midpoint between 2 points and the distance between 2 points. Now this is the last thing that I'd like you to do on linear graphs, and it's a little bit of an extension exercise, but it's really quite simple when you have a look at it. So the first idea that we want to think about is the midpoint on a line. And so when you're thinking about questions like this, you're going to have a couple of points on a line. Now I'm just going to choose a random couple of points here that are at easy spots, or what I mean by that is easily sort of defined coordinates. That's probably a better way of saying it. So what do we got here? We've got 2, 2, and this one here is at -3, 2. Now, where's the midpoint between those going to be? Now, we know that it's going to be at this point here. So this is halfway between the two. But we want to be a bit more mathematical about that. Now, there's a total distance of 5 between this point and this point. So along the x-axis, we're going to have to be 2.5 higher than this point here. Now the y values are the same, so they're not going to change at all. So our midpoint here is going to be at -0.5, 2. Now that's not that hard to figure out, but also this is not a very easy way to work this stuff out. So there's probably going to be a better solution. Now what we are actually doing is that we're taking the average of the x values and the y values. Now the y values were both 2, so the average y value stays at 2. The x values, well, we had -3 plus 2, so we're taking the to take the average divided by 2. Now -3 plus 2 equals -1 over 2 gives us -0.5. So the x mid is that. The y mid is again the average of those two, but because they're the same, it just comes out at the same thing. Now let's have a quick look at another one of these. So it's a slightly trickier one because our we've actually got a line that's on a bit of an angle. So let's have a look at some of the points here. So we've got 1, 2, and down here I can see that this goes through -3, -3. Now look, we can do this the old-fashioned way if you like, just by thinking about it. So I can see that going from left to right there's a total of 4 squares, or going +4 from this point across to this point. So my midpoint is going to be here on the x-axis. Now on the y-axis I'm going up 5, so I would have to go up 2.5 to get my midpoint here, so it's going to be at -1, -0.5. But again, that's a painful way of doing it. Let's try and do it mathematically. So the x midpoint is going to be the average of the two x values. So we get -1. Now that's exactly what we figured out down there. The y midpoint is going to be the average of the two y values. So it's -0.5. No need to try and simplify that any further, which again is what we got there. So all we need to do to get the midpoint is we take the average of the x values and the average of the y values, and we've got the midpoint on any line, or the midpoint between any 2 points. So as long as you know what the points are and you're confident of the coordinates, that's pretty easy to work out. The next one is only maybe very slightly trickier, and it's where we're thinking about the distance between 2 points. So let's start off with a horizontal line again, because that's nice and easy. I'll choose 2 points. So my point here is at 2, 2, and my point here is at -3, 2. Now when I'm looking at these, I can see that I've got a distance of 5 between them. But we want to do this a little bit more mathematically. Now, what I think we should do when we're doing these as well is always work from left to right. So the way that we do when we're working out gradients and things like that, just because it's a good habit. Now, mathematically, what we're doing here is that we're just getting the distance, now I'll just call that d, is just going to be, in this case, x2 minus x1. So it is going to be 2 minus minus 3, which is a distance of 5. So that's pretty straightforward. But this is just a horizontal example, so we don't have to worry about y values. So it gets a little bit more complicated when we move on to an example that's not horizontal or vertical. Now, what I'm going to explain to you now is a system that will work with any example. So rather than going, oh, well, we do this for horizontal lines and we do this for lines on an angle, I would suggest that you just use the one technique. So we're going back to the one that we've used a little bit now. So we've got this point here, which is at 1, 2, and we've got this point here, which is at minus 3, minus 3. Now, this is obviously a bit trickier because I want to figure out the distance between the 2 points along the line. But that's not something that's easy to measure directly. But like we've seen before, we do know a couple of other things about what's going on here. Now, these are meant to be straight lines, but they aren't. Now, we know that we've got a run across from here to here, and we also have a rise going, well, actually, it would have been better if I'd been going up, but the rise going up this side. Now, if you look at what I've just drawn, I've just made a right-angled triangle. Now, it's really easy to make right-angled triangles on a Cartesian plane because you've always got your x-axis horizontally and your y-axis vertically, so you can make right-angled triangles pretty much anywhere you want to. Now, what this means is that we've got two sides of our right-angled triangle and we've got our hypotenuse. So we can use Pythagoras, that we all know and love from one of the earlier topics we did, in order to figure this out. Now, just as a little aside, trigonometry and Pythagoras are incredibly important if you are going on with any kind of higher maths or physics. They're just really useful skills all the way through mathematics, and so they are things you want to make sure that you can do okay. So, going back to the example, now B is the rise, and A here is the run. Now, we know that when we're thinking about our right-angled triangles and working out the hypotenuse, well, c squared equals a squared plus b squared, or the hypotenuse, c is the square root of a squared plus b squared. Now, we know from what we've done previously that the run is x2 minus x1, and the rise is y2 minus y1. And we can replace these values in here with those values from the coordinates on our Cartesian plane. Okay, so distance equals the square root of, so we've got the rise, in fact I'll start with the run, plus the rise, and from that you can work out the distance between any 2 points. Now, one good thing about this is that it's actually really hard to get it wrong. Because we're squaring everything and we're adding in the middle here, it doesn't actually matter if you get your x values the wrong way around and your y values the wrong way around. It will always work out the same, although you can always mess it up by forgetting to minus things and that sort of thing. But I would say try to do it this way and it will always work. So let's check our example here. So we've got, in this case, x2 minus x1. Well, that's going to be 1, oh, that's a terrible line, 1 minus minus 3 squared plus, now y2 minus y1, y2 is 2 minus minus 3. Okay, so what do we get? And sorry, that should be squared. Square root of, well, 1 minus minus 3 is 4, and I can see that I've got a run of 4 from here across to here, so that makes sense. I've got 4 squared plus, now 2 minus minus 3 is 5, and you can see that I've got a rise of 5 squared. Now I'm going to work that out on my calculator. And, or actually I'm probably not because I can't find my calculator, but 4 squared is 16 and 5 squared is 25. Add those together and I get the square root of 41. And you can figure that out on your calculator. So that's distance. It's just working out or using this formula here to get the distance between any 2 points. So just think that you're using Pythagoras to figure out the hypotenuse, where the rise and the run are the other sides of the triangle. Okay, I hope that helps. You should be right to work on the last set of exercises now, and that's the last thing you should be doing before you do some chapter review and prepare for the test.